Well, hello.
Awkward silence.
That was fun. What should we talk about?
I think we should talk about domain-driven DevOps.
Someone should stop that. Is that me?
Stop which? Are you getting an echo? Do you have the YouTube open somewhere?
Probably.
It was fun for me when I had to figure mine out too.
Technology. Andrew is muted and he's struggling. If only technical people were good with computers. We'll cut it all out, Andrew. Don't worry.
No worries. So the page that was resting on the YouTube was open and then started playing. And then the other problem I told you about having too many tabs, it like pushes them to the end. You can't even see which tabs are making the sound. So you got to dig through it. Anyway, we're back. Drinking cold
Relatable
beer.
problem of having too many tabs.
Yeah. So where were we? We're talking about some domains.
Domain-driven DevOps.
I mean, let's just smash all the buzzwords together.
Yeah.
See what happens.
Yeah, I mean the full title is Domain-Driven DevOps Demystified. So we're gonna
That's the title of the
demystify.
workshop. But first, we got to have a thing before you could demystify it. First you need to mystify. Then
Okay,
you,
so what is domain?
Are we demystifying the workshop, or are we just demystifying domain-driven DevOps? That's the real question.
I think we should start with
Let's
some
start with the
definitions.
domain. What is domain-driven DevOps?
Start with some definitions.
Let's start with domain-driven in the first place. So domain-driven has meaning. So what does that vocabulary mean? We'll pass the mic to Jay Bloom.
So domain-driven design is a community built around a book by Eric Evans called Domain-Driven Design. And it argues roughly that we need to kind of build models of domains. So, and a domain would be like a group of people working together on some idea, like, an office or a business. And so you need to, in essence, be able to express what is happening in the domain, in your software, in the same language that the people doing the real work in the real world do. So if someone says, for instance, I'm a tax collector and I use tax forms to submit taxes to the government, you should have a method that says like submit tax form to government. So that when they say that out loud, you can literally see it in your software. And that, in theory, makes the kind of mesh between end user requirement gathering and software development typing easier to keep control of. In theory, like there's some arguments about like it could prevent some forms of technical debt as well.
The way I usually explain it to myself is anchoring the idea of shared metaphor from kind of like the original formulation of XP.
Yep.
And then connect that to the value and possible necessity of having experts from an actual domain involved.
Yep.
And then so you cross-pollinate those two ideas and you end up with a system that has some model, some shared metaphor that you can reason about and have jargon for, semantically dense conversations about, but it's also representative of that domain in a way that people get value from doing that exercise instead of just wandering into abstraction land.
Yeah, and also like avoiding the translation layer a little bit, right? Like when you talk to the domain expert, the conversation shouldn't be significantly different than trying to work with the software.
You're trying to minimize the impedance mismatch between that emerging metaphor that you're using for developing the software with the actual domain.
Yep, that's right. Yep. So it's like a form of software architecture built around like understanding, again, domain experts better. So
then from there, what does DevOps mean? That's a loaded question.
Wait,
So I thought the whole point was that you refused to define it for the rest of
That is
eternity.
such a misnomer. That's like not true. I actually gave a very defined definition. I just refused to codify the practice of it.
What was your very defined definition?
Well, the original one was 3 points about how software is one that software developers and operators should work together. Like that seemed controversial at the time, and in some organizations still. Two, that software or that operations was evolving to look more and more like software development, and that we could take advantage of all the lessons and tools that we built around software development and apply them to operations. And then three was that there's this global community of practice that's emerging, and that we can all leverage each other's understanding and experience to solve these problems better, instead of everyone having to figure everything out from first principles every single time. And then that evolved to my more kind of pithy version, which is just sort of adding on to the software's eating the world and software's eating operations, which is DevOps is about optimizing the human performance and experience of operating software and with humans. And
So I
and
think
there's a bunch of layers there, and implied socio-technical systems.
so interesting part of this is a lot of people went with the first one, right? So like culture, let's all be friends and work together kind of thing. And a lot of people went with the second one, which is, let's just make operators into software developers and then everything's going to be better, which is not my favorite way to approach this problem. And then I feel like no one went with the third one, right? So like, so the devsays.org, right, and all of the conferences are exactly that, like, right, community of practice, all of these people coming together and sharing experiences and sharing their expertise, so that not everybody has to make the same mistakes over and over again, right? But if you look at where kind of the marketing around DevOps terminology evolved, no one actually talks about the community of practice. People talk about tools and people talk about collaboration. No one talks about sharing experiences.
I think part of it is what people think they can sell, and that lots of what gets projected into the zeitgeist is a function of what the marketing department people pay for. And when you look at the origin of most of these things that got put into it, and we can come back to that for a bunch of other topics, that they're either trying to sell you consulting to help you change your culture, or they're trying to sell you a tool. And it's the same reason that certain types of things won't get validated, quote unquote, by science, simply because there's no way to monetize it, right? So then doesn't get done. But at the same time, the way you started is sort of counter to where you ended, because like DevOps Days does represent that. It's just not like the people who get it, and the people who don't, it's one of those if you have to ask, you'll never know type of situations.
Yeah, so I completely agree with you. So like that's the problem with buzzwords in general, right? Like every word you invent to represent a theme or a concept gets co-opted by marketing of various organizations who are trying usually to sell you a product.
We know it is working when that happens.
Right, but then it gets kind of bastardized in every possible way. And then the other problem is, and we're going very fast into our favorite discussion of like how people adopt the words without adopting the concept, right? And that's where it creates problems. But I feel like we went away from what's domain-driven DevOps. So we talk about domain-driven software architecture. So what do we mean by domain-driven DevOps?
So there's a couple things to think about, and the way that I usually would start this conversation is if you look at where domain-driven design came from and then what it's sort of adding on to the agile conversation, the majority of those conversations started in a world where software was something that was shipped on physical media, and operations was not a problem that that group or that community had ever had to deal with. It was effectively an external cost that was borne by the customer or the consumer or whatever. So you make software, you ship it, it goes on, CD and shrink wrap on a truck, and then you make money, whatever. In the middle of that conversation, and largely what I would consider the forcing function for the rise of the DevOps conversation, is software delivered as a service. So what I want people to realize, and you can apply this to a lot of other conversations, is software is only valuable when it is operated. It has to be operable. And a lot of organizations have architecture or design that is somewhat isolated, insulated from some of the operability impacts of their decisions. And what I would like people to, and there's we can get into more detail about what's the infrastructure, what's the platform, what's the software, all of which are now as a service, and all of which now have operational responsibilities. But most organizations, I mean, even now you see like everyone wants to build and no one wants to maintain, no one wants to operate, and that's causing more problems than it's solving in most organizations.
Yeah, I'm gonna jump in and no one wants to operate. You see it even in the like SRE discipline, because like we're talking about SRE are like the people operating. I mean, we can argue about this, but SRE are the people operating, and yet SRE kind of specifically try to drive toil out of the system, but toil is operating. Like you know what I mean? Part of your job is to implement things to improve the software, but part of your job is just to operate the software, and one of the parts doesn't work without the other. And then sort of naive implementation of SRE is like, let's just reduce toil, let's just remove toil, like let's make toil 10% of the system, and all other time our SRE people are going to be writing code. It's like, which code are they writing? And who's managing your freaking software? Like who's answering incidents, and who's learning from the system, and who's doing that work?
I think that's an advanced implementation, to be honest. I would say the more naive implementation of SRE is to change the titles and nothing else, and to frame it as essentially the same as the old model, where the SREs are there to take the burden away from the software engineer. So I'm all in favor of driving toil out of the system. What you want to avoid, and like we could go into a pretty deep rabbit hole about what is toil and whether toil's actually bad, but in general, humans are not particularly good at doing repetitive tasks. And I think that they're better, although we'll see where the generative AI puts us in the next few years at creating. And so you want to take these sort of repetitive, undifferentiated tasks out of the system as much as possible, and use your humans and their creative minds to create solutions to the problems that you have. And some of those problems are operation related, and some of those problems are deployment related, and some of those problems are operability related, right? Operability, observability, like there's all these subgenres of the DevOps conversation that have their own discipline and have their own kind of software investment required. But over and over, one of the things that I've seen in my platform development efforts from the and we can name all the vendors that I work for, but you can also look it up. At the end of the day, like people are kind of shocked at how much software development needs to go into that platform in the first place, and two, the ongoing operational burden that you created for yourself by creating that platform.
Yep. I think so. The other thing I would say, right, is like SRE to me is not just about removing toil from the system. It's partially about like creating architectural principles that prevent toil from showing up in the system. Kind of like to use the kind of terms people used to use, there's a certain amount of necessary toil or essential toil, but there's a lot of accidental toil that just comes in through a gate because no one is trying to figure it out. And to kind of like link this back to the DDD stuff, right? Like DDD is a lot about software architecture, as in code, as in optimizing the system to be, intelligible by software engineers. So what we end up with is like another question. I think it's hard to even kind of pronounce correctly or point it correctly. I think of it as as architecture in operation, as in like there's a set of things you have to do as an architect now to consider not the software as a bunch of text that needs to be manipulated by human brains, but that now it's a bunch of things that needs to be operated by human brains. And this part of it over here, this architectural part, is largely just, invisible to most people. Like they don't know how to think about it. And I think, the best kind of version of SRE would be, upskilling the software engineers who are giving you the stuff through things like PRRs and things like this to prevent the toil from coming over in the first place. But secondarily, to add quality to the software by engineering the software itself to be more operable, right? Those are the two kind of sides of the coin that need to happen. And I think that's largely missing from like what we need to do as SREs is operate the software. Like you need that secondary kind of level. There's a meta level to it. We need to make the software more operable, not just do we need to operate the software better.
And that also gets into this notion of the enabling constraints that come. So if you think about the way domain-driven design conversations are usually taking place, that there's some model of this software and some services that you're going to build across these domains interact with each other. Then those all have a service component, which means there's the operations component. Someone's got to operate that software. And I make that point to get to this sort of straw man argument people make about the misquoted Werner Vogel's thing that you build it, you run it. So you have each of these different domains, if you will, that have their own service, and maybe the people that are writing that code are going to have insights into how it should be operated, how it should be running. But there's a layer below that. When Werner Vogel says that at Amazon in 2006, it already is an API-driven platform and API-driven infrastructure. So when you go to as a service model for the software, the platform, and the infrastructure, each of those have an independent operational consideration that's created. And each of those teams, depending on the model and depending on the shape and size of the organization and maturity of what you're going to get into, could potentially be different roles and responsibilities. So the infrastructure as a service has an infrastructure development component that is, there you could even break down domains inside of that. That is going to be producing some operational service. And then the platform is going to be built on top of that. To me, that would be these abstractions about how you're going to do, the role-based access and the different data services. And then as you come up to that top layer where the domain for the software lives and where more classical conversations about domain-driven design, those also have an operational burden. And so I like to make these very, very explicit so that the organization can then make explicit choices about each of those different responsibilities and who's going to be on call essentially for each of those different layers.
And this is partly like what I mean by like, so in old school software architecture, you could have a layer model like this, and you would assign responsibilities to the different layers. Like the business logic should live in this layer and the data should live in this layer and blah, blah, blah. It's a way of describing where the software engineer should be focused on certain aspects of the system, right? And the layers are supposed to isolate those things, blah, blah, blah. When we talk about kind of like the idea that software architecture now, again, we can't just ship it and be done with it. Now, software engineering is also software operations. It's the same. These are no longer kind of like things that can be clearly separated. They're stuck together in this service model.
Whether you like it or not.
Whether you like it or not. Then the layers of responsibility and the assignment of responsibility from an architectural perspective is more about where will certain parts of the system operate in abstraction from the other layers, and so that we can isolate those things and make sure that they're just like in any other kind of layer cake software architecture. We want to isolate the operation of the thing as well as the kind of software engineering of the thing. So where do the responsibilities live, and how do we get those things to occur becomes an interesting question. And I think it's one of the questions why people have a hard time with differentiating like infrastructure as code, self-service, versus a platform. Like they don't understand that they don't have a language for describing what the responsibility of the platform layer is. So they end up saying it's self-service, and then you go say, okay, with self-service, what? I get a bunch of components out. And you're like, well, so you're basically getting wrappers around infrastructure pieces? That's what you're self-servicing? Is that really a platform? Well, I don't know.
It's the difference between going to the supermarket or going to the the sushi on the conveyor belt or going to the omakase.
That's right. Absolutely.
Well, I think in many organizations, platform doesn't exist, or there's a bunch of different platforms, or there's a platform, but it's not actually adopted by the majority of people in the organization. So like, I think kind of trying to define platform a little bit better, and also talking to like, why do we want an opinionated platform in the first place? Isn't it better to have all the freedom of choice, and I can, implement in this tech stack or that tech stack, and I can choose this database or that database, and I can, write in this language or that language. So as a developer, that sounds great. Like, why can't I have that?
So I would take a slightly different, nuanced part of this platform discussion and go back to the beginning of the NIST definitions for cloud computing, and that's also the same three layers, right? So you have software as a service, platform as a service, infrastructure as a service. And what I would argue, and this is even what I argued from the beginning, if platform as a service exists, then platform as not a service has to also exist. My argument is everyone has a platform. That platform might be sending an email to the girl that does the work, right? Or that might be the phone call. That might be the ticket system, ServiceNow, and the doit5.sh in my home directory. So I would say that if you can do anything that deploys software, anything that operates software, manages it at all, you quote unquote have a platform. It's not a good one, and you can do better, but there's a platform or you have no software. That's my argument. And I actually want to take and break this down a little bit, because I think this clarity will help people, which is if you just sort of think of these three layers as the code that we wrote that has our business logic, this kind of like middleware stuff that like connects the web server to the database, and then this like operating system kind of like lowest level, connect to the drivers, connect to the machine, then that existed even like before cloud, whatever, like those three layers existed. So all we're doing as we move into this cloud native as a service model is blowing them up. And then what I aspire to do, and I aspire to help other people do, is be able to independently in isolation update each of those layers. And that's aspirational and easier said than it's done, depending on how you've kind of coupled them and smeared them together. But if you architect these things in such a way, that buys you a bunch of leeway to be able to keep those things coherent and keep them from delaminating while independently updating your own code, the platform code, and the infrastructure code. Now, granted, those might have different time scales. They probably do, that you're going to update your own code on a quicker cadence than probably the platform, which is also going to be quicker than the infrastructure. But if you kind of get to this mentality, it buys you a lot of leverage with respect to scalability, with respect to operability, with respect to recovering from failures. And that is to get to this point, which is in order to do that, to keep those things separate and to keep them from delaminating, you have to make choices, right? And so those enabling constraints that you are going to make deliberately are what are going to allow you to have each of those layers be adding to the enabling constraint will add to the productivity without sacrificing those other promises you want to keep about those other things, the ilities that you want to keep. That's how I think about it.
Speaking of promises, to me, what this all means is that those pieces need to be separated by an API that promises you a contract that you can trust and that's going to be consistent and that it can execute the things that you think it can execute, right? So like the reason cloud was amazing is it created an API around, say, the infrastructure piece, right? And then I could trust that, like, if I say create me a server, it will create me a server. And that just took a lot of the headache away, but it doesn't mean I cannot do this on-prem. It means that people on-prem didn't used to do this, right? So you actually had to physically go in and put a server into a rack and wire it up and play with it until you got the OS up and running and stuff like that. And so like taking that headache away and being able to trust the layer below you to just serve your needs. Like I don't care what's down there, right? I just want to be able to consume it and trust that it does what it promises to do.
Yeah, and I think
slightly. Go ahead.
I think like one of the things that happens if you get this to work right is this. APIs don't just work by fulfilling a contract. Part of what they do is they isolate the implementation from the consumption, right? And so the really interesting things that you can start thinking of is like, why do SLOs work the way they do? Well, because you don't write in an SLO, I need a quad core machine with this type of RAM, with this type of thing. You write down, I need to process this much data within this period of time. And then you say to someone else, it's your problem now to figure out how to serve this load. So you have to figure it out. And I think that's really important to think through because in our 3-layer cake, there's different timings or different time pressures, right? So at the top of the cake where you kind of got application stuff, the timing is driven by markets, right? So like how fast can you respond to the market? How fast can you adapt to the market? Can you get into niches quickly? Things like that. And there's a certain kind of speed there or a certain kind of ability to be responsive. On the other hand, you go all the way to the bottom and you're primarily driven by physics questions. And what I mean by that is it's kind of like, speed of light problems, things like this, but also Moore's law is what's driving the replacement of the hardware. It's like Moore's law doesn't care about your opinions at all. Right. And so there's
Moore's law is failing, right? And so like we're not actually increasing the speed of computers as fast as we thought we would. But there's another thing which is like you get into trade-offs, right? Because like your really low level architecture of your, say, cloud or data center is also starting to impact your decisions after that. But again, ideally, if I'm developing software, I shouldn't care about this. I care about my features that I want to ship tomorrow, right? And I shouldn't care about how data center below me is implemented. I just care that it's going to fulfill the promise that it's made of me.
Yeah,
absolutely.
But I think that the other thing that you kind of brought up before that resonates with me a lot is by having unlimited choices, we're increasing that operational burden, right? So like by having all the platforms or all the tech stacks or all of these things like kind of freely available, where like someone bears the responsibility. Someone's getting up at night to fix this shit, right? And it's like, if it's not the developer, it's someone else, but someone has to deal with that.
So this argument I make about a lot of things, but I more or less try to see what other people are doing and learn from their mistakes. And one of the things that you see fairly consistently across the cloud natives, whatever that word means, we can come back to. But when you said a minute ago that the APIs and like people couldn't do that, circa 2005, 2006, 2007.
AWS API mandate, right?
No. Not even AWS. AWS was the ones that productized it. But every like medium scale web company could configure from scratch, from on bare metal machines in their data center with an API, like every single one. And we helped build a bunch of those systems at the time. And that was like the table stakes to be able to do all that work.
So I think what I thought the example you're going with though is, say, at one point there was a big mandate at Amazon to have everything API driven, right? And that was like, if you don't have an API, you cannot have a service.
I was going to get to that. So you have these API driven provisioning in all these web companies. Great, that's fine. But you also see, if you go to the Netflixes, the Amazons, the Googles, they don't let you run whatever you want. They don't. And then you get into the enterprises, and there's like some weird, like ritualistic approach to developer experience, and like we're going to let the developers do whatever they want. And it's like that is not the pattern that worked to do this at scale with velocity before. So maybe you want to let your developers have these choices, right? So
I'm going to ask you a question, because I asked you this more than once, and I feel like I'm going to ask you on the podcast, so now it's going to be on record, so now you have to answer. Like, most enterprises don't have choices. Like, so like, I mean, everybody gets into a point where they don't have choices anymore, right? Because you paint yourself into a corner. And it doesn't matter how good your initial architecture was, right? Sooner or later, you're going to run into some issue that you didn't anticipate. But like, most enterprises grow through mergers and acquisitions, and they have no ability to create this consistent platform, and they have no ability to like invest a boatload of money into rewriting everything from scratch to create the consistent platform. So like, how do you deal with that if you can't have nice things?
So the idea that you can go from wherever you are to an ideal state at the snap of a finger is like, there's just a lot of problems with that idea. At the same time, either as an individual or an organization, you can recognize what you do have, what time you have, what abilities you have, and you can make investments in those abilities, whether you're talking about yourself as an individual or as an organization. Now, in specific, thinking about modernization of a legacy portfolio, without getting into like the details and specifics, I usually try to help people think about the big buckets that they have, and then from there try to get to some platform that can accommodate those buckets. So the first thing that I would think about is kind of going back to the point Jay was making a minute ago, is, are there things that we know we need to change rapidly? Like, we want to be able to accommodate some opportunities in the market, so we're going to make the investment in those to get to this new architecture that will let us do all the buzzwords, continuously DevOps microservers, right? Like, let's do that. Let's make that possible for those things. And then as you go down in the portfolio and get to the kind of like, like at the bottom of a lot of these things, there's mainframes, and they're going to slowly like get strangled, right? So there's some methodological approaches to strangling those out, but in order, the priority, like, let's do the things that we know we need to change fast. And then the second thing I look for is things that we know we're having problems scaling, or we know there's like these other problems that we want to keep promises about, but it's causing whatever problem. And we want to get those architectures in this thing where we can keep those promises. And then the last one that I look for are things that are very expensive. They could be expensive because they're creating a lot of that operational burden, or they're expensive because of licenses, or, and now a lot more and more people are causing expense with their cloud investments too. But if you look at those three buckets, if something doesn't need to change fast, doesn't need to kind of scale or keep other promises about latency or whatever, or it's not expensive, like, just leave it. And so because it's not causing you problems, it's actually whatever, it's kind of fit for its purpose, and just leave it, and then use that to find ways to get more resources in the time you saved with the operational burden you don't have to fight now to make a new strategy with the old stuff. I think also organization, this is like a slightly different conversation than when we started with, but there's this notion of kind of like removing, right? And these models of resilience, we talked about these biological models and autophagy, or the way that bones are constantly being built up and torn down. Organizations really suffer because they never really tear themselves down. And I don't mean that in like, let's just riff random people from across the organization, but being thoughtful about, does this particular architecture, does this particular investment, does it bear the weight that we need it to bear? And then what is the incremental improvement that we can make towards that ideal future state? Instead, I see over and over that organizations just layer new things on top of old things on top of old things on top of old things, and it makes it really, really hard to unwind that whole stack. Where if you were thoughtful about the end of life and the removing of things, then you get more optionality for the future things to be built the new way.
I think I see this, but I also see that like the opposite example of like, oh, let's just rip it all apart and replace everything from scratch, and this then becomes a multi-million-dollar project that is doomed to fail because just
that always ends in failure. I mean, like there's a few exceptions, but in general, I see the pattern of the big rewrite usually ends in sadness.
But it's interesting how like people again paint themselves into a corner with like, they will keep some of the constraints of the system, and then they will try to kind of band-aid the remaining stuff to like, oh, it's still not working. Like, okay, why did you keep the crappy parts of this?
I had a mentor pretty early in my days as a engineer programmer person. He actually wrote the O'Reilly book on Make way back in the day, and he had this kind of joke, but it's a metaphor for a bunch of these problems, that you need to get to the third system as fast as possible because the second system is always doomed. And the reason is because everyone tries to do every single thing that the first system did and all these new fancy things without really thinking through like the engineering trade-offs, and also a lot of the second systems, because of some of the stuff we just talked about without respect to operations, people like think up what it would and could be like in this dream world, and then when that investment meets reality, it doesn't always end well.
So there's another thing, and this is like I see it more as an industry pendulum that swings all the time, and that like people come and they say, we see problems with this architecture, right? Monolith sucks because, and then I list 10 reasons. And I'm like, I'm going to solve all of these 10 reasons with Kubernetes and microservices, right? And then I don't ever ask the question, what was Monolith good at? What did it do really well that made it work for people for fucking 40 years? Sorry, language. And then like I write it all from scratch, and then I'm like, oh, I guess I needed local storage in Kubernetes because all of these people can't function without it. So now I'm gonna backtrack and rewrite it. Like if we just started with like what was good about the previous architecture, we wouldn't have these problems, I think.
Sorry. There are conversations happening right now, and really since the beginning of the microservice thing, around what monoliths are good at. I would say in some ways this goes back to a cycle that like spawned object-oriented programming as this kind of like it's this thing, it's going to save us all, right? We're going to have all this reusable code and like none of these problems. And then we have microservices, which are effectively the same kind of argument, except we're just going to put a bunch of network hops in the middle of all these services. And the reality is, if you can't write well-factored performant code in a monolith, then the idea that microservices is going to somehow make that better for you is pure folly.
Let's replace all the complicated.
Let's replace all the local calls with HTTP and see if that increases the performance of the system. That seems totally reasonable.
Let's take a tightly coupled system that has like can't fail the API calls by virtue of like not having an API, and now let's make APIs and network calls in between all of these things, and then scale them independently and have all of these queues we don't know how to manage, and then somehow it's gonna.
This goes back to the buzzword, rubbing the buzzwords on everything strategy, and the problem that marketing ruins everything. Because what happened in so many cases with so many places is they essentially built distributed monoliths that can't be independently updated anyway. So you didn't get any of the benefit of the microservices. You got all the downside of the microservices. That also leads into this conversation. Like I don't know. I try not to roll my eyes in front of customers too much, but when you talk to someone and they've got a microservice initiative and a continuous delivery initiative and an SRE initiative and a DevOps initiative and a platform engineering initiative, and they're all different. They're all in different part of the org chart and they're not talking to each other. You're just like, okay, like let's see what we can do here. Because when you're talking about microservices, you imply a platform, in my opinion. And the same thing with continuous delivery too, because what you are doing when you make a microservice architecture is you are creating more deployments and more operational considerations for yourself, right? So if you think about continuous delivery, that's more deployments in time. Microservices is more deployments in space. So if you haven't made that investment with your automation to drive down the operational burden, the operational cost of those deployments, then all you really did was make more work, more toil for yourself.
So I just want to kind of say this out loud. There's no problem with microservices. There's no problem with the cloud. There's no problem with any tools you want to use, except like to gain benefit out of an advantage of using the tools, you have to like use the tool that's appropriate for solving the problem.
There's no problem with a hammer, but not everything is a nail.
Yes, that's exactly right. And so the problem we have in our industry and probably other industries, I'm just familiar with this one, right, is that once we get into this, like, let's all do DevOps transformation, and then now everybody's doing the DevOps transformation, and it like doesn't matter if so. Now I do think some things,
but they're not. Going back to our original thread from early in this conversation, they're doing what was marketed to them, or whatever kind of like some executive and org chart and funding model allow them to do.
No, I think to me, like some tools will always improve your life. Like having some sort of CI/CD tool will never hurt you. I have not seen any example of a use case where having a CI/CD tool was worse than not having one. But there are examples in which adopting a particular software or a particular platform is just not good for you, and it's going to hurt you more than it's going to help you.
So I'll add to that. So I totally agree that that not all tools are fit for all purposes. But going back to this notion of it, I've never seen it hurt someone. I'll say it this way: that there are way better ways to use some tools, and just because you have this tool doesn't mean that you're using it the right way. And I think every tool.
I mean, when we start kind of seeing CI/CD bump into governance issues, right? And then the issue ends up being, oh, wait, we gave everybody the ability to build their own pipeline in many, many different kinds of ways. And now we need to figure out how the hell to govern that after it's already been like spewed across the organization. So, again, it's like, it's not, the problem isn't just that you have a hammer and a nail. The hammer's like a rabbit, just now there's 1,000 rabbit hammers, and they're everywhere and they're all different colors. Tribbles, maybe they're tribbles. I don't know. Anyway, so that's part of the problem, right? Part of the problem is that, people who've never made a hammer before, who don't know the qualities that hammers should have, start, manufacturing things that are hammer-like. And then you walk around, you're like, everybody's got a slightly different variation on this. Now, I'm not
repackage whatever they sold before as hammers.
That's right, exactly. Yeah, this is also a hammer now, right? And so, but I don't like, again, from an economic perspective, right? There's a cost to having absolute control, like to make everyone use the exact same CI/CD pipeline. That would have a cost to it. And I don't think that's the argument I'm making. I don't think you should force everybody through the same system, but you should have some architectural conception of what you're trying to achieve with a CI/CD pipeline, instead of just saying, okay, we've got, our CI/CD pipeline tool is in the house. Go for it. Go use it.
Or basically, you're saying, like to Andrew's point is like automation is not always going to make your life better. And there's many, many reasons that we can make a whole podcast about, like,
It's
why.
not always the constraint
So-
on the system.
It's not always the constraint. Yeah.
But you can, like, automation is also a great way to make mistakes speedily and at scale. And
Scaling
also
failure. Yep.
automation also requires maintenance, which is, the thing that kills
It is
most
now
systems.
software, and all code is a liability.
Yep.
All code is technical debt. Okay, so I do feel like, so if I listen to this entire podcast from the outside, I feel like I still wouldn't have like a really clear idea what do we mean by domain-driven DevOps. So like, I
Then
just want to put
mission,
you all on the
mission accomplished.
spot.
Domain-driven DevOps remystified.
I mean, this is great. We can now create a whole marketing copy for our website about what domain-driven DevOps is.
I think partially, like, again, like to think about it like we were at the beginning, and to apply it, for instance, to the CI/CD pipeline stuff, right? Like, CI/CD pipelines need to be architected, and they're not currently architected. They're not seen as something in operation. They're seen as something that you need. It's a tool. It's some sort of inert thing that you just apply. Rub some CI/CD on it, right? And the answer is no. That's not right. You need to have an understanding of the architectural principles you want people to understand. You need to have an understanding of the responsibilities for the different parts of the pipeline. Maybe some patterns for the basic way you construct these things, have an opinionated way that they're deployed. And then when when your opinionated platform, your opinionated CI/CD platform, meshes with reality, some of the things will have to be tweaked around a little bit, but at least when we come through the organization and look from one part of the organization to the other, it's not like someone has literally reinvented CI/CD from one team to the other. Yeah.
So I think one of the problems that we face, and it's related to the buzzword and the marketing stuff, is everyone's looking for this kind of concrete paint by the numbers thing they can take home and implement. And if you think about what domain-driven design represents, you effectively have a community of practice with some nuance and some definitions where they all argue with each other about what those things mean. And then in the DevOps land, you have all the things that we kind of touched on, where there's ambiguity and there's different levels of understanding about what those things mean. But then also, to tie it back to what Jay was just saying, that those things should mean different things to you given your context. I think one of the things that's been problematic for a lot of the DevOps conversation is that people see the web ops cool kids doing a thing or talking about this thing they did at a conference, and they go back and they try to do that thing that way, and that's not their. They don't have
two options, right? There's like, we could never do this because we're not Google, or we're gonna do it exactly like Google, right? So
yeah, and that's like the two sides of the canyon that are both bad, right? So
because humans don't like grayscale, right? We want white, black. Like we don't like to be in the depends on context, right?
maybe speak for yourself, but I think that there's like no, I love like context and ambiguity, but my problem with a lot of these attempts is that everyone wants it to be simple, and it's like, no, you have a complex context. What is your winning condition? And then let's work back to your preconditions, and then make a plan from there for what domains make sense for your specific business, and what context can we apply to that based on what you can do. Because related to a lot of the
sounds expensive and complicated, and these other guys promised me a pipeline.
Well, then, that's why you're failing right now with the pipeline that you paid them for. Everyone wants to take the pill, right? Like, everyone wants to take the pill and have the six pack. But if you really want to do the thing, like, it takes work. And, this is related to a lot of the other conversations we're having. It doesn't make sense for you to know what the perfect ideal condition for yourself is if you can't do it. If I tell you that your workout should start with doing 10 pull-ups and 25 push-ups, and you can't do one of either, like you have no way to make progress.
I mean, even worse, right? To me, often you're going to train learned helplessness into that group. Like, you need to do 25 push-ups, but I can't. No, but that's what you need to do. Okay, I can't do DevOps. I'm not able. We can't do that here. That type of stuff, right? So, we need to have these kind of incremental ways of doing it. But the other thing, like, when you try to take something like, the way that Google does platforms and you apply it somewhere else, right? The thing to understand is the grayness that you're talking about, Sasha, is like the bunch of design decisions that were made to fit that platform to a particular context, to make it work in that context. A bunch of design decisions. So when you pick it up, if you don't understand even what decision, not why the decisions were made, but what decisions were made, and you apply it somewhere else, and it doesn't fit to that context, you have no way of like reshaping the system. So, part of the adoption of things is just trying to understand what are the design decisions that need to be made. Like, what are the levers that need to be slid back and forth so that I can fit the platform into my context, right? As opposed to like, again, they drive Mack trucks at Google, so I guess I should modify my garage so I can have a Mack truck too.
Yeah, so much of what gets shared is kind of like a dressed up, idealized version of the part of the iceberg that's outside of the water, right? And so like that's what we can see, and we can maybe try to copy that superficial part. But there's a lot of things under the water, and if you don't have something that looks like that under the water, then that stuff outside the water doesn't matter.
Right. There's a lot of problems, right? Because like you distill something to a model, and then all models are wrong, right? And then you potentially, through broken telephone, someone who's teaching me the model never actually implemented the model and doesn't understand why the model exists and stuff like that. But then like so the problem we're all facing is like, then to fix this, you need, the language expert, right? And people think that they can't afford the language expert, and they end up paying, 100 times more for making the same mistakes over and over again, but not hiring the kind of the help.
But I mean, worse, right? In so many organizations, what's happening kind of metaphorically is they're hiring bilingual people, or they're hiring bilingual consultants to come in and patch the organization together, and they either then become dependent on those consultants and they can't get rid of them because they're an interface layer now, or when the consultants goes away, people go back to having kind of complete mismatches. They can't talk to each other anymore.
Or third option, which the consultant didn't even know what they were doing.
Right.
Yeah,
Absolutely.
I think there's another thing that's happened in multiple places, especially now that there's been. This is interesting because it's going the other way in some cases, where someone went and hired someone from one of the FANG companies or something and brought them into their bank or whatever enterprise, and then one, they didn't have those preconditions, and two, they didn't really empower that person to change some of the things they would have wanted to. So there's a bunch of that happening. Another thing that's interesting in the current situation with some of the economic decisions, there's this flood of the engineers that have been in some of those organizations, and for a variety of reasons, they've enjoyed whatever their time and kind of their experience. And there's an article that just came out that a lot of the startups are frustrated with their hires from some of these companies because they're so accustomed to maybe those opinionated platforms and how those kept promises for them, or some of the other perks that they enjoyed in those organizations.
Yep.
Yeah.
How do we run the end buffer, the thing that says we're done? We should do it again next week though. This was fun. We should try to figure out how to get more people to come and hang though. Just like have people come.
We can actively invite people.
Right, that'd be cool. That'd be fun.
If you watch this and you want to come argue about something with us, you should let us know.
We will argue for sure.
It appears that this platform will let us have 10 people on the stream. So let's see how many people can argue at the same time.
Let's see if we can.
We'll have to get Roger's rules running, you know.
Should we call it a day and get back to work?
Yeah, we should definitely. So, so thank you anyone who joined and anyone who's watching this later. And we promise to make more content. And yeah,
I heard
hopefully
Sasha.
you learned something.
Yeah, well, click the button.
That was fun.